Hi everyone, welcome back. Hope you're doing good. This is Mahesh. In this video and in the upcoming videos, we will completely learn on arrays. So in this video, we will try to understand what is an array. Basically, we will get some introduction on the array, and in the upcoming videos, we will try to understand how to operate with arrays, and we will solve plenty amount of examples on arrays. So by the end of this particular series, you will completely get acquainted with arrays and how to use these arrays in order to solve multiple problems. So in the subsequent videos, we will solve many problems that are there in the LeetCode, which are mapped to arrays. So let's get started. So what exactly is an array? So basically, array is a linear data structure where all elements are arranged sequentially. So basically, let us assume this is some structure, and if you see, there are elements or there are spaces where we will be able to store the elements in multiple blocks. So they are stored sequentially. And it is a collection of elements of same data type stored at contiguous memory locations. So when I was showing this block, these are contiguous memory locations where we use array elements to be stored in these particular blocks, and we store them sequentially, like one after the other. We cannot leave something blank in between. Correct, right? Now, arrays are among the oldest and most important data structures, and they are used by almost all the programming languages. You consider any programming language, you will hear the concept of arrays in all the languages. Now, let us try to understand these arrays with an example. So assume we have 10 32-bit integer variables with indices 0 through 9, may be stored as 10 words. Assume we are trying to store 10 words at memory addresses starting from 2000. Okay, and it goes till 2036. In hexadecimal, you can see it is 0x7d0 till 0x7f4, so that the element with the index I has address 2000 plus I into 4. What exactly this means? So we know, right? I mean, whenever computer stores some information into it, what it does, it will store the information in terms of bits, 0 or 1. Correct, right? But now for the end user, it is some integer variable. If that is the case, somewhere there should be a conversion that is happening from integer to these bits. Correct, right? Now what we understood, it's a 32-bit integer. So there will be, if we take one integer, there will be 32 bits. So we will see data from 0 till 31. So totally it is 32 bits. So if you are trying to store one element, it is of size 32-bit internally. That is how our computer stores. So 32 bits, in the sense, it is 4 bytes. Okay, so 4 byte means each byte will be of size 8 bits. It is equivalent to 1 byte. So we call, if there are 8-bit blocks, then it is called 1 byte. So such 4 bytes can hold one 32-bit value, one 32-bit int value. Okay, so if that is the case, now what we know, we have 10 integer variables. Okay, so it means we have created 10 blocks, something like this. Okay, so each block is of size 32-bit. Each block is of size 32-bit. Correct, right? If that is the case, if you see here, each memory address is pointing to 1 byte. So it means for storing a 32-bit value, we need 4 bytes, right? So 1 bit starts at 2000. For one integer value to store, it starts from 2000. This stores first byte. This stores first byte. 2001 stores second byte. 2002 stores third byte. 2003 stores fourth byte. Correct, right? So if that is the case, from 2002 to 2003, we store one 32-bit int value. 32-bit int value. So that's what we are trying to say. So assume we are storing the value at 0th index. If it is a 0th index, then if you substitute that here, what it will become? 2000 plus I is 0 into 4, which is 2000, because 0 into 4 will be 2000. Now assume we are trying to store the element at first index. If that is the case, it will be 2000 plus 1 into 4, which will be 2004. So we saw here, right? Our one integer value starts storing from 2000 to 2003. The next value will start from 2004, which we can see here, right? That is where it is getting started. So this is how internally each integer value gets stored. So what we understand here, our computer stores value only in terms of bits, either 0 and or 1. Now these blocks which holds 0 or 1, so they are memory blocks, and if at all we want to store or we want to address a particular memory block, then we will consider 1 byte of memory and we will address it with any address, hexadecimal address value, something like this, 0x7d0. So such 4 blocks combined together, they will store one integer value. So that is how internally the storage happens. Okay. Next point, the memory address of the first element of an array is called first address, or it is a foundation address, or it is a base address. That's the first address, we normally call it as. Now, arrays are used to implement other data structures such as lists, heaps, hash tables, dequeues, queues, stacks, so many things which we will learn eventually, but we just need to keep this in mind. We will learn about, we will use arrays to implement other data structures. Okay. Now, when the data objects are stored in an array, so basically now we understood here, right? We use these address locations and we store the data. So if you consider our array, so if you are trying to create an array, maybe somewhere it will store something like this, then maybe you will end up storing the values. But what happens now, each block will be mapped to some index value. So some index value is, in the sense, it is going to be a positive integer. It normally starts from 0 or 1 or something else that we will see later. So that is how whenever a value is stored in an array, it gets mapped with an index. So if you want to access that particular value, then you can use that index to access that particular value. There are 3 ways in which the elements in an array can be indexed. One is zero-based index. If it is a zero-based index, our first element in the array starts with 0 index. So if you want to access first element, then you need to access that using 0th index. If it is 1 based indexing, the first element of the array is indexed by 1. So if you want to access the first element, you need to access it with using index 1. And n based indexing, the base index of an array can be freely chosen. Usually programming languages allowing n based indexing also allows negative index values and other scalar data types like enumerations or characters or something like that. Okay, so normally when we say arrays, so most support zero based indexing. Okay, now let us try to understand about one dimensional array. So, or it is also called single dimensional array, one dimensional array or single dimensional array. It's a type of linear array. Accessing its elements involves a single subscript. Subscript is nothing but index. Okay, can either represent a row or a column. So whenever you try to visualize an array, so you can visualize something like this, which is kind of row. It is a single row array, or it can be something like this also. It is like a column, single column array. So that's what we can understand. Now there are other arrays also, like two-dimensional, multi-dimensional array, three-dimensional array, and then comes multi-dimensional array. So in the two-dimensional array, what happens? We will have rows as well as columns. So if you see this particular um, diagram, so here there are 4 rows and also there are 4 columns, correct, right? So if you want to access any element in this particular array, then you will need two values. You will need two values or two indexes. One is index, one is row index, and another one is column index. So this is column 0, this is column 1, this is column 2, this is column 3, and this is row 0, this is row 1, this is row 2, and this is row 3. And if you want to access this particular element, this belongs to column 2 and row 1. So this belongs to row 1 and column is 2, because this is 0 and this is 1. So that's why it is row 1 and column 2. That's what is represented in each block here. Okay, so now let us try to understand how the array stores elements whenever we initialize the array and then we initialize the array with elements. So now let us take this example where I want to store 11 numbers, 11 integer 32-bit numbers into my array. Okay, so normally what we do, we say int some variable name array and it is of type int, and we say its size as 32 something like this, sorry 11 something like this. So it means I want to create an array of size 11 which holds integer numbers. Okay, so if that is the case, now what we understood, it is a 32-bit int number that we want to store in each block here. So if that is the case, 32 bits is equivalent to 4 bytes, because 1 byte is equal to 8 bits, correct, right? So each 1 byte will be allocated with one memory address. Okay, now if that is the case, we need 4 memory addresses to store 32-bit integer number. Now if you see, I want to store 11 elements. If that is the case, for each element I need 4 bytes. So total bytes that is required to store 11 32-bit integer numbers is 44 bytes. Now when our program executes this particular program executes, how the memory allocation happens. Randomly it will allocate some memory to this array. So this array will be allocated with some memory, let us say 200 in this case, in this example. It can be anything. So this 200 is not really the, I mean, it is the decimal number, but in real case, it won't be the case. It will be a hexadecimal number. Okay. Now, with this, what it does for array from 200 to 244, memory locations are allocated. So these are reserved for my array. So this is how the initial reservation happens with respect to memory. Now what I want to do, now I want to store my number 11 into this particular array. So 11 gets converted into 4 bytes, then they are stored from 200 to 203. Correct, right? Next, we push 9 into the array. So again, its 4 bytes are stored from 204 to 207 and so on. It will continue till 244. So now assume all the 11 numbers are stored into the array. Okay. Now I want to access my maybe fifth number, which is this 90. So how do I access? I mean, in program, it is going to be array of 5. But when we have stored these numbers, they are stored on some memory locations. But now I am trying to access using this particular index. So now what our computer does or our program does, it will take this index 5, then it will convert it into memory location. How it converts? So we have, it will take the initial location of the array, which is 200. Then what it will do, it will take index, which is 5, into each integer will have 4 bytes. So multiply by 4. What we get? 220. What we get? 220. If you see here, for this particular number, the address location is 220. That is how we access the number from the stored array. Let us take one more example. Let us consider this 9. Again, index 9. Then how we get the memory location? 200 plus index into 4. So that is nothing but 200 plus our index is 9. It will be 236. If you see in the example here, it will be 236. That's how encoding and decoding of the memory locations happen in the. Now, let us try to understand, I mean, how these individual blocks looks like when the values are stored inside the computer. So now for us, for representation, we are using one box, right? This is 11. This is how we are storing. Now this 11 is nothing but a 32-bit number. So 0 to 31 bits. So total 32 bits. For, I mean, this is the full block, and out of this full block, there will be like 4 bytes of 8 bits. This is 8 bit, this is 8 bit, this is 8 bit, and so on. This is nothing but 1 byte. This is 1 byte, and this, the other two are also 1 byte size. Okay. Now, if you see, on a whole, for the representation, it is a single block, but internally it will have 32 blocks, and each 32 block will be addressed with 4 memory locations. So each of 1 byte. So this will be addressed with 200. This is 201. This is 202, and this is 203. This is for one block or storing one number. So the same representation happens for the other numbers as well. About the arrays. So we will learn how to access these arrays, or how to add elements, how to remove elements from the array in the upcoming video.